All right, so quadratics can be used in many different ways. What we are going to focus on is mostly area optimization, okay? So let's take this situation here. We got Drake, all right? He recently visited the Huntley Farmers Market and has decided to enter the game, the gardening game, that is, all right? Drake has 300 feet of wire fencing to make a rectangular garden enclosure. He wants to keep those deer and other, rabbits and things like that out. Now, he plans to build the enclosure against an existing retaining wall. So he only needs to enclose 3 sides. All right, so what we're looking at is we've got ourselves a retaining wall. We'll say that this is our retaining wall. Retaining wall. And then the garden itself, we'll do the wire fencing in blue. It will only need 3 sides, okay? So it's using that retaining wall as the 4th side. And it says, what dimensions should he make it so that he has the largest possible garden? How many square feet of garden space will he have? Okay, well, we could just take a guess on this, right? I'm sure many of you are thinking that right now, like, I don't know, just guess. But there is actually a way to figure this out and know exactly what dimensions we should use in order to make it the largest possible area, right? So you could either go with like a really skinny garden, right? You can go with one that's a little more square. I think there's a lot of different possibilities here, but we can math it out to figure it out. Okay, so let's say this. Let's say I've got that this dimension here is x. I don't know what it is. Well, if it's a rectangle, then the opposite side has to be congruent to it, so the other side is x, all right? Now, most of us are probably thinking, well, why don't I just go with then y right here? Have 2 different variables, or like length and width. Well, here's the thing is it's kind of tough to work with 2 different variables. So let's think it out. If I've got 300 feet of wire fencing, and I used X amount for this side, and X amount for this side, I'm left with 300 minus 2X. Now, if you didn't follow that, let's do a what-if situation. Say this was, say, 50 feet, which makes this side 50 feet, which means I'm left with, well, 300 minus 50 is 200, right? I'm just subtracting out what's being used. In this case, though, I don't know what's being used, right? I'm using X amount. So let's get rid of this stuff so we don't get confused as to what the heck's going on there and why all of a sudden we had 50s and whatnot. Okay. So essentially, I can write my dimensions in terms of X. So this becomes 300 minus 2X. So those are my dimensions. X by 300 minus 2X. Okay, cool. So what do I do with that? Well, how do I find the area of something? What's my function for finding the area of any rectangle? Well, area is equal to length times width, or base times height, or whatever. I like base times height best. Base times height. Okay. Well, let's just say my base is my X, and my height is my 300 minus 2X. I'm just multiplying my 2 dimensions together to get my area. Okay. Now, if I were to distribute that X, I'm going to jump down here. Area equals, I'd have 300X minus 2X squared. So I'm going to rearrange this into standard form. Negative 2X squared plus 300X. Well, that's a quadratic. I don't have C over here. C is just 0. That's okay. But I've got a wonderful looking quadratic that if I were to graph it would look like a parabola. So let's actually graph this thing. I'm going to zip this down a little bit so we get some more room to work. If I were to graph this parabola, it would look something like this, right? It's negative. That negative out in front makes it an upside down parabola, right? Okay, so if that's an upside down parabola, right, it's negative, it'll be like an N shape, and it's saying that I want to maximize this garden space. So I want to basically figure out, well, what X value would give that function the largest possible number. So really I'm looking for this point up here, which is called my vertex. Okay, if I figure out what that is, that's the maximum height of that function. That's the highest point, the largest numbers. Okay, so my area function, a equals, or a of x equals, let me write that out, a of x equals negative 2x squared plus 300x. If I find out the max height of that function, where that thing is at the top, the vertex of that, that is the largest possible area, okay? Because it's area as a function of x. Area as a function of my dimensions. That's what this is saying over here when you have a parentheses x. So how do I find my vertex? Well, if I plug it into x equals negative b over 2a, that'll give me my x coordinate, and I can plug back in for my y. Hence the previous video. Let's do that. So if I plug my info in here, I'm going to have negative 300 over 2 times negative 2. So 300 divided by 4 is 75. Okay? That's my x value. So let's write that down up here. 75, comma, what's my y value? How do I find it? Well, I got to plug that into the formula. So negative 2 parentheses 75 squared plus 300 times 75. That gives me my y coordinate, which is 11,250. Perfect. Awesome. All right. So what do these numbers mean? Well, if 75 is my x value, the 75 is this dimension, which is also this dimension. And then if I were to subtract 2x from 300, so 300 minus 2 times 75, that would give me 150. So my dimensions, what dimensions should he make it so he has the largest possible garden? It would be 75 feet by 150 feet. And then it says, how many square feet of garden space will he have? Well, there's actually two ways of looking at this. You could be like, oh, well, 75 times 150, and, ooh, look at that. That gives you your y coordinate. So he has 11,250 feet squared of garden space. All right. We got our dimensions. We got our area that he's going to have. He's good to go. Drake's ready to enter that gardening game. He knows exactly what to do with his fencing now to make sure he's got the largest amount of space. Woo! Lovely. All right. So, real quick recap on this. My area function, when I maximize that, when I find that highest point on the graph, that tells me, first off, this guy right here is my x-coordinate, which is my dimension, and then the y is my a of x, right? My area when I have this going in for x. So this tells me my max area, and this tells me the x value that will get me that area, which I can then plug back into my diagram here to get my two dimensions. All right. Yeah, you could do some guess and check for something like this and like keep on trying different numbers. It could take you a long time, especially if you have really large numbers you're working with. So mathing it out can be a very helpful time saver. All right, even though it is a little bit complicated. All right, so we got Snoop Doggy Dogg is opening a doggy play place on his farm. How exciting. I didn't even know he had a farm. That's pretty cool. He plans to enclose a rectangular space for the dogs that backs up to a river that runs through the property. So again, only needs to enclose 3 sides to keep all the dogs in. He has 1,680 feet of fencing to use to make the enclosure. What dimensions should it be so the dogs have the maximum amount of room to run around? And also, how many square feet will the space be? Okay, well, let's figure this out. Kind of a similar, basically same type of situation as the last time. Not kind of. It's the exact same thing. So we got this river, right? Whew, river. And then you've got the fencing. So we got a fence that makes it a rectangular enclosure like this. Okay, and we got to figure out what are those dimensions. So again, we can assign a random dimension. It doesn't matter which one you do, whether you use this side or the other side. I usually do this because then my opposite side is also x, and then I only have one side where it's like written with like a more complicated expression. So I have 1,680 feet of fencing, and I got to subtract out what I use. So minus the 2x. There's my other dimension. So 1680 minus 2x. feet. And this is x feet. Cool. So I've got my drawing here. Well, how do I figure out my area? As we did last time, I have my area function. My area as a function of x, meaning as a function of one of my dimensions, is equal to, well, my one dimension times my other dimension, 1680 minus 2x. And if I multiply this out, I'm going to have 1680x minus 2x squared. And again, I'm going to rearrange this into standard form just so I don't make a mistake when I plug things into my formulas to help me analyze this quadratic function. So here is my area function in terms of one dimension, right? And then the other one's built into there with the diagram that I have. Awesome. So we want to figure out how to maximize this function. And to do that, let's think what we're looking at here. We've got a quadratic that's going to look something like this, okay? I'm looking for that vertex up at the top, right? That's where this function is maximized. That's where I'm going to get the most perfect, wonderful dimensions to give these dogs the largest area to play around in. Okay, so let's do that. I'm going to use the x equals negative b over 2a to get my x coordinate. So that is negative 1680 over 2 times negative 2. You'll see a lot of similarities with these types of area problems because the way they work out is basically the same thing each time. Okay, so I end up with x equaling 420 feet, right? So 420 feet for that dimension. Well, how do I find out my other dimension? I can just plug 420 into it, so 1680 minus 2 times 420, that gives me 840 feet. Awesome. So there's my other dimension. So if I'm getting my dimensions there, my dimensions would be 420 feet by 840 feet. Cool. All right, so I've answered the dimensions that it should be. Now, how many square feet is it going to be? Well, I could just multiply those two together, and it will get me, so max area is 352,800 square feet. Oops. Feet squared. Started writing a 2 instead of a T. All right. That's a nice little dog park they got there for Snoop Dogg. Another way I could have figured this all out, I could have taken my x-coordinate of the vertex and plugged that into the function. Let's see, just for fun, just for some good laughs here, does it give us the same answer? If I plug all this into my calculator, click, 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 yep. And it does. 352,800 would be my y-coordinate of the vertex. And that makes sense because my y-coordinate is my a of x, my area as a function of x. So that would be my area, which I got also just by multiplying my dimensions. I think multiplying the dimensions makes more sense intuitively, but just as a general note, a math note, you could plug it into the area function and get that. Really, I could plug in any number I want into this function right here, and it will give me my area. I could plug in 50 for x and find out what my area would be if I did 50 by 1680 minus 100, right? If I plugged it in here, I could figure out what that area would be and so on and so forth. So maybe you end up just kind of guessing and checking or oh, I have to get around something, whatever. You might have to change it out. You won't be able to get the max area. Just depends on the situation. For our purposes, totally fine what we did up there. All right, but the first starts with writing that function to figure out your vertex, which is your max point, to give you your max area, and your dimension that would give you that max area. All right, lovely. Well, Snoop Dogg's happy, I'm sure, because we helped him figure that out, and now he can go ahead and open up that doggy play place. I wonder what he'll call it. You know, Snoop Doggy's Dogs, right? That's good. Snoop Doggy Play Place. Your dogs be snooping and pooping. I don't know. You know, maybe something like that. Because dogs love to snoop around, right? They're just checking it all out. I don't know. There's lots of names. Maybe we could comment on the best name in the Ed Puzzle video and see what you guys come up with. All right, lovely.